Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks. Been busy. So sorry about the delay to this 2396 resuming. Where are we? Right. So this is carrying on outcome 2. So we started outcome 2 and then we put a gap and we did a cable calculation video. Hope you had a look at that. So let's just do the back end of outcome 2 and then probably I'll do a maximum demand video, or I'll probably do a separate maximum demand video and then we'll pursue with outcome 3. So where are we? So this is the back end of outcome 2, understanding the installation's design, construction and commissioning process. Okay, and it applies to both the practical and the written. You see there's 3 questions in the practical section or the project section, and then there's going to be 2 questions in your big written exam. Fine. Okay, so back end of outcome 2. The learner's going to need to explain the process for designing distribution circuits. Okay, so distribution circuits naturally is where we're connected to the point of origin to a board, to a distribution panel. It's not a final circuit. It doesn't stop. So when you think about the design aspects of that, we'll take, as you can see here, the assessment of general characteristics into account. Number of type of live conductors, the incident energy levels, prospective fault currents, the ZEs and things like that. Also, we need to bear in mind that if we have a distribution circuit that has quite a long length or a small run, we'll have the volt drop problem. We did mention that in the cable calculation video. When you do a distribution circuit, you don't want to achieve maximum volt drop. You need to make sure that your volt drop is fairly low so that the circuits, maybe even further distribution circuits going onto it, or final circuits, have an allowance of volt drop. Volt drop is total from the origin to the final point of utilization. So a distribution circuit should really just barely touch the volt drop allowance. Similarly with the principles of earth loop impedance and things like that, we don't want to put in a circuit that's going to basically shaft the person who's going to then have to work on the end of that. Interestingly though, we do have to we have a nice opportunity to play with maximum demand and diversity for distribution circuits, because when we think about obviously a final circuit, we can assume the demand and we can calculate a circuit according to that demand. But when we have a number of circuits, we have a number of demands, and we're going to feed a circuit that actually then supplies their distribution point, we can take consideration that the equipment isn't going to be on at the same time, or the use of the system won't be simultaneous. There may be, demand equipment, peak equipment, off-peak equipment. It might be that you can't use one item when you're also working the process on the other. And this is where we can diversify the use of the electrical installation, and we can take that into account, and we're going to cover that in the maximum demand diversity videos. But it's really distribution circuits is where we really will actually need to put that into practice, because if we don't account for diversity, we're going to have excessive cables, which for your project will just look ridiculous. With regards to the designing the process of distribution circuits, we're going to have to consider the general characteristics, we're going to have to consider the volt drop, and also consider maximum demand diversity there. We will, outcome 2.4, the learner will explain the method of determining maximum demand, including diversity. We're going to do a video on that, which kind of shows you the method. Now bear in mind, there are a number of methods. There's a common old method of adding things up, dividing them by the number, and all that. That's really just a shot in the dark. There's also people who have written books saying that the service fuse is the maximum demand. No, that's crap. There are proper ways to assess maximum demand. Some software can do that, but the best way to do it, especially for the 2396, is to use the methods adopted in the on-site guide as a guidance. Similarly, if you've purchased the IET's design book, it takes the on-site guides methods and just pushes it further. And we'll probably use those methods in the video. We'll just use the design book's methods. You could be a little bit more practical. For example, I mean, this project is a training environment, and you'll probably find that the drawing will say we need to have a 110 volt or a 16 amp socket in every single test bay. Now you know that that is only there to actually have a supply to test a temporary installation. So there's no way that those 16 amp circuits are going to add up to 16 amp. They're not going to have any demand at all, really. They're going to be energized for testing. So you may have to just, you know, be a little bit smarter with your diversity consideration on the project. But we'll cover that later on. All right. But for an explanation of how to explain it here, we'll cover that in a video very soon. The next one, 2.5, explain why specifications may alter during installation work. I mean, this is kind of a common sense question. You can put a plan in, you can have a plan that will work well, but no plan ever works well. Nothing ever goes to plan. It could be a change of design on a client request. It could be a change of design that's been forced due to some other issue with another part of the building or another builder. There are a number of reasons why. Okay, so don't have to worry too much about that one, but we'll probably put a part of it into the project anyway, just to give it as an example. 2.6, describe the commissioning and handover procedure of electrical installation work. So we understand that you test it, but we have to be a little bit more in depth than that. So we obviously consider what the testing is. It's part of the initial verification process, requires the production of certification, the electrical installation certificate, the schedule of inspections, the schedule of test results. You'll also have to provide drawings, manufacturer's equipment, manufacturer's instructions. If you look at guidance notes 3, actually right at the introduction, it does mention the operational manual. I think it's literally at the bottom of the first of the introduction page, and it tells you all the stuff. So you need to think more about that, about the handover part. As fitted drawings, yes. Okay, so here's a couple of pictures there. So you understand your schedule of test results must be completed. You understand an as fitted drawing. I mean, it depends on the scale as to what your drawing looks like, but you don't want your drawing to be on the back of a fag packet, for example. It needs to be an understandable drawing that the client can use. And the operational manual. Now with the operational manual, you will need to obviously check that any equipment, switchgear, or any in this case residual current monitors, installation monitors, just make sure everything is set as it should be. Okay, and do make sure that if you're putting it into a manual, that the user has instruction on how to maintain or monitor these settings. A great example of something that's always overlooked here is something as obvious as the RCD testing. We put that sticker on the consumer unit, says test quarterly. The amount of times I go to someone and I'm doing a gap analysis and I say, do you do your RCD tests? And they'll just look at me with a dumb face, not knowing what the heck that means. So you've got to pass instruction to the client to allow them to effectively maintain the electrical system, to maintain its life, to a suitable level until the next routine periodic inspection. All right, so be concise and be clear with what you're trying to get across there. 2.7, the learner will identify techniques, keyword there, for providing this information relating to electrical installations, design, construction, and verification. So what? It's a very awkward kind of outcome question. What methods or techniques are there to give information to the client? So I mean, we have drawings, we have the manuals, manufacturer's documentation, certification, the specs, any requests of the client's requirements, any recommendations to the electrical installation. So there are different techniques to give information to the client. Okay. It's one of those funny questions, really, or funny scenarios that they bring into these things. Okay, so it's not what should you give them; it's what techniques are there to provide information to the client. You can even do things like meetings and things like that. There are different techniques, but make sure you're passing the information over effectively. That is the back end of outcome 2. That's obviously combined with the first video of outcome 2. I will now put together a maximum demand on diversity video. I could either make it very small, or I could do it. I might make it into 2 parts, one being the demand, one being the application of diversity. It might just be a bit easier. Yeah, we'll do that. Alright, see you in the next one, guys. That won't be long.